Welcome back to Azure Services Deep Dive from Data Analytics Actuary. In previous episodes, we covered VMs, VM scale sets, and app service, compute platforms where you think about applications or fleets. Today, we go fully serverless Azure Functions, where you deploy individual pieces of logic that run in response to events, and you pay only for the compute you actually consume. Azure's platform is designed so services complement each other at every layer. At the bottom, virtual machines give you raw compute. In the middle, app service manages your application runtime. At the top, serverless services like Azure Functions eliminate infrastructure entirely. Across all three tiers, the same networking, security, monitoring, and identity services apply. For data professionals and actuaries, Azure Functions are the glue layer, the lightweight automation that triggers models, transforms data, and reacts to events without standing up servers. Azure Functions live in the compute category, in the serverless tier. Serverless doesn't mean there are no servers, it means you don't see them, provision them, or pay for idle time. Azure manages the entire underlying infrastructure. Your function scales from 0 instances to thousands based purely on incoming event volume. When nothing is happening, nothing is running. When 1,000 events arrive simultaneously, 1,000 function instances execute in parallel. This is the most elastic compute model Azure offers. Azure Functions, a serverless, event-driven compute platform that runs individual functions in response to triggers, HTTP requests, timers, queue messages, blob uploads, database changes. You write the logic. Azure handles everything else: provisioning, scaling, fault tolerance, and billing. The consumption plan charges you only for execution time, measured in milliseconds. If your function never runs, you pay nothing. Let's unpack how functions actually work. A function has two parts: a trigger and code. The trigger defines what starts the function: an HTTP request, a timer on a cron schedule, a message arriving in a queue, a file uploaded to blob storage, or a document inserted into Cosmos DB. Bindings go further. They let your function read from and write to other Azure services without writing connection boilerplate. Azure Functions supports C#, Python, JavaScript, TypeScript, Java, and PowerShell. The runtime handles dependency injection, scaling, and retries. For stateful workflows, Durable Functions extends the model with orchestration patterns. Fan-out, fan-in, human approval steps, and long-running sagas, all expressed as code, not YAML configuration. Here's where Azure Functions solve real problems. First, event-driven data pipelines. A file lands in blob storage, a CSV export from your policy administration system. A function triggers immediately, parses the file, validates the schema, transforms the data, and writes it to your analytics database. No polling, no scheduled task manager, no idle server. Second, scheduled actuarial jobs without dedicated servers. Your monthly reserve calculation needs to run on the first of every month at 2 a.m. A timer-triggered function fires exactly on schedule, kicks off the computation, and terminates when done. You pay for those minutes of execution, nothing more. Third, API backends that scale to 0. An internal API that's used sporadically during business hours costs nothing overnight and on weekends. HTTP-triggered functions respond to API calls in milliseconds and scale automatically as concurrent requests increase. Fourth, real-time IoT and telemetry processing. Sensor data streaming in from connected devices is processed, aggregated, and alerted on by Event Hub-triggered functions, handling millions of events per day without any infrastructure management. Azure Functions are deeply wired into the Azure ecosystem. Azure Event Grid routes platform events, blob uploads, resource changes, custom events, directly to functions, enabling millisecond reactions. Azure Event Hubs connects functions to high-throughput streaming data, processing millions of messages per second. Azure Service Bus provides reliable message processing with built-in dead letter queues for failed executions. Azure Cosmos DB's change feed trigger fires a function every time a document is created or updated, perfect for real-time data sync and downstream notifications. Blob storage bindings let functions read input files and write output files without any storage SDK code. And API management exposes functions as managed, secured, documented endpoints with rate limiting and developer portals. Serverless isn't free of trade-offs. The biggest one is cold start latency. On the consumption plan, when your function hasn't run for a while, the first invocation triggers a cold start, loading the runtime and your code from scratch. This can add 1 to 3 seconds of latency, which is unacceptable for user-facing APIs. The premium plan eliminates cold starts by keeping instances pre-warmed, at higher cost. Default execution timeout is 5 minutes. Long-running processes need the premium plan's 60-minute cap or a durable functions orchestration. Functions are stateless by design. Local variables are gone the moment execution ends. And complex trigger chains, functions calling queues, can be difficult to debug locally without a careful tooling setup. To bring it together, Azure Functions are the right tool when your workload is event-driven, when demand is unpredictable or spiky, and when you want to pay only for execution time. For actuarial and data teams, they're ideal for automating data pipeline steps, running scheduled models, and building lightweight APIs without the overhead of maintaining application servers. The constraints are cold starts and statelessness. Keep your functions short, focused, and event-driven, and they'll rarely let you down. That was Azure Functions. If this was helpful, please subscribe and turn on notifications for the full series. Next up is Azure Kubernetes Service, the managed container orchestration platform that lets you run complex microservices architectures at scale with automated upgrades and self-healing deployments. I'll see you in the next one.